So hey everybody, I'm Cary and this is Phillip. We're machine learning engineers at Primer.ai. And today we're going to be talking to you about how we streamline our process for model creation and inference and getting NLP products out the door.
Yep. So yeah, we'll just start off with a little bit of context on some of the problems that Primer tries to solve. Talk about some of the problems we face trying to deliver those solutions, and then talk about why declarative NLP is really well suited for those problems. Talk about some of the benefits of that and recap with some of the takeaways.
Sweet. So what do we do at Primer? You might have heard of us, maybe you haven't. We'll let you know a little bit about the products that we create. One of our first products that we created was called Analyze. It's a new summarization, aggregation, and exploration tool that helps personas like analysts collect information about really anything that could be happening in the news worldwide so that they can make better decisions.
Another one of our products is about providing visibility on real-time streams of social media and classified data. So as a user, somebody who's in the intelligence space, and they need to monitor events that are developing quickly over time, this kind of hits that use case for them.
And then one of the things that we've been getting into lately is we have customers that use these tools that we just mentioned, and they want to add custom type of, entity extraction to the type of information we pull out of news, or maybe we're looking for customers that just have a bespoke type of use case for their workflow, and they want to create some sort of NLP solution for it.
Yeah, so we're an NLP company, and along with that comes a whole suite of problems. So for our products that are mostly ingesting streaming data, like handling those workloads, we need a solution that's kind of hits all of the requirements, from being fast, high reliability, it needs to auto scale, needs to be cost effective. Running on GPUs is inherently expensive, and it needs to be flexible enough to support sort of any model framework that a data scientist would want to use. And so there's really no simple way to solve all of those requirements, and inherently it's going to require a complex solution.
The solution that we've come up with in the past for a lot of these problems is, okay, we're going to have Kafka to queue in different messages. We have streaming problem. We're going to use Redis as a cache. We need to be able to auto scale if we get bursts of all sorts of messages coming in at once. And like Phillip just said, this complexity can become overwhelming, especially when maybe you're a data scientist and you're just like, okay, I created this model for this problem. You told me I need to be able to identify science entities in data. How do I get this into our tooling? It can be maybe not obvious if you're relying on a stack that's fairly deep.
And so for streaming workloads, we have that set of problems, and also for training custom models, like, we're training on big data sets, large NLP models, and we need to do that across distributed hardware. And so trying to kind of hide the provisioning of those resources and all of the kind of work it takes to train at scale, where you're doing parallel cross-validation, large scale evaluation, and you need that to integrate with your ultimate serving solution. Like, there's a lot of complexity that goes along with that.
So the way we approach this is we wanted to create declarative APIs for our NLP infrastructure. We wanted to make it really easy for our data scientists to get and manage the type of hardware that they need to actually run their models, and not have to worry about the types of problems that I mentioned a couple of slides ago, like, oh, how is this message coming off of a Kafka queue? What if I need to be able to access it asynchronously? How do I process these things in batches? We want to be able to hide a lot of that complexity.
Yeah, so instead, if you're a data scientist or model author, and you have, you've taken the time to train and develop some model, and now it's time to embed that into your pipeline or your application or however you want to use that, like you really, at the end of the day, just want to be able to call that at a production endpoint, an endpoint that you know is going to scale, it's going to handle whatever you send to it, it's going to be fast, it's going to be cheap. And by leveraging the paradigm of declarative APIs, you can declare what you want and use it instead of interacting with an API that's more imperative, where you have to tell it how these things should be provisioned for you, how it should provision Kafka, Redis, and all the underlying pieces that are needed to give you what you ultimately want.
So the way we did this was with Kubernetes custom resources. Kubernetes is declarative by design, and so it offers APIs to extend its APIs, he said, in kind of a meta way. And in the same way that Kubernetes allows for the composition of different resources in, like we said, a declarative way, we extended it to be able to allow for our NLP infrastructure to be served on Kubernetes.
Yeah, so we can take a look at what the declarative API for model serving looks like. So again, instead of having to enumerate like all of the things that you want and how your endpoint should be provisioned, we expose a higher level API that lets the author simply state what they want. So really just letting them focus on what's needed to initialize the model. So this CRD is basically specifying like just the basics of, do you want a GPU or not? Maybe some other stuff about the hardware, and then ultimately just initializing some model that is abstracted in a Python class. And so the model author really just needs to come with an implementation of their model as a class, and the system is kind of separate from that, in that it doesn't need to be tightly coupled there. So we can get out of the data scientist way and be flexible for them.
Similarly, we have problems where we want to be, having users train models where they might not want to actually get into the nitty-gritty details of what hyperparameters actually went into it. They might want to just look at the performance metrics to come out of a particular training request, but they don't want to deal with getting GPUs or thinking too hard about like what the actual getting a model from training into production to deploy it is actually going to look like. So we created an AutoML declarative solution. You see similarly, here's a custom resource that is implemented with Kubernetes, and the user just needs to specify the data and make sure that it conforms to a schema that we expect depending on the actual model type, and then they can just get on with training. And what comes out is a class, a set of YAML that allows the user to actually pass that model to our serving system in the same custom resource that Phillip talked about a moment ago. And we can easily allow a user that trained a model on our training system to just move along to deploying it, all without ever having to worry about, where did my training hardware come from? Where am I storing these models? I just need to make sure that I have an S3 location. Is everything going to integrate? Is it going to be available in production? They don't need to think about those things.
Yeah, so I guess another requirement for these serving and training solutions is that they have to be able to run in pretty much any generic environment. A lot of primary use cases are for kind of confidential data, and so it needs to be able to run in maybe any cloud provider, government clouds, even all the way to air-gapped environments. And one of the side effects of going with this declarative approach is that it allows you to have sort of a static view of all of the assets that you're deploying to an environment, which allows you to do like static security analysis and apply any sort of extra config or changes to those manifests that you need to deploy them into a generic environment. It also lets data scientists sort of trust that, if they're deploying their model on this solution, that it will just go ahead and work in the generic on-prem environment. And so they can more focus on like, again, get back to just focusing on the quality of their model and how that's implemented.
So the important things that we've learned from this journey are that declarative APIs allow our users to actually care about what their thing is going to do, not how it's actually going to be implemented. And this has allowed us to get a lot of models that were previously fairly slow to get into production, both trained and served really quickly. And it allows us to serve in many environments. And we have, a very wide variety of environments Phillip just mentioned we need to be able to deploy to. So that was it from us. Feel free to reach out to Primer, our LinkedIn, our blog's linked here. Feel free to reach out to Phillip or I directly. We'll happy to chat over email.